right, welcome back to New Learning, folks. You were in the middle of Unit 7, the quadratic unit, when school was canceled. So we're going to do a little bit of review in this lesson before we move forward. And you had learned how to solve a quadratic using graphing. You labeled all the parts of a quadratic, and basically to solve by graphing, you were finding the roots. Roots being the x-intercepts. X-intercepts are where the graph crosses the x-axis, and hopefully you would notice that any point that is sitting on the x-axis has a y value of 0. So the rest of the unit is going to deal with algebraic ways to solve for those roots. So to find those answers without drawing a graph. One of those ways is to solve the quadratics by factoring. Not every quadratic formula or equation can be solved using factoring, just some of them. And we are going to work on the ones that can today. So the process for doing this is that you set the equation equal to 0. So that's kind of saying the function is 0, and that would be the y value of 0. So you're trying to find the x values where y is 0. So set the equation equal to 0, factor it completely, which you did back in the beginning of the year, and then set each factor equal to 0 and solve, and that's the new piece. So the factor completely chart has been put into this lesson to remind you of what you did way back then, and we will take a look at number 1. So number 1 said first step was to set the equation equal to 0. Well, the equation is already equal to 0. Everything is on the same side. So we are now on the factor completely step. To factor completely, you look for GCF first. I have 3 terms. I do not see any number or letter that goes into all 3 of those terms. So other than a 1, we have no GCF, and 1s don't help us, so we move on to the next step. I notice that I have 3 terms in this quadratic. The question says, is there a number in front of the x squared? No, there is no number in front of my x squared, so I can take the shortcut, which is just go straight to parentheses. If you're a person that likes to do factor by grouping all the time, you can. You will get the exact same thing that we will. All right, so if there's no number in front of the x squared, then when I do front times back, it's really 1 times 18. So I'm really only worried about the 18. What multiplies to 18? Make a list. 1 times 18, 2 times 9, 3 times 6. We need a pair that adds up to 9. That would be this pair. But I notice that in the middle term is negative 9. So anytime you have a pair of numbers that adds up to the right number, but the sign is wrong, you always change both. Negative 3 times negative 6 does make a positive 18. Negative 3 plus negative 6 makes the negative 9. Now, the shortcut is, instead of doing grouping now, since there is no number in front of that x squared, those are the numbers that will end up in parentheses if I were to do grouping anyway. So I'm going to go straight to parentheses and skip that grouping step. All right, the third step said take each factor, that's the stuff in parentheses or anything on the outside if we'd pulled out a GCF, and set them equal to 0. So x minus 3 could be 0, x minus 6 could be 0. Helpful hint, when you're solving equations, the highest exponent in the equation tells you how many answers to expect. So if we're doing an x squared problem, we should get 2 answers. All right, so if I add 3 to both sides here, then one of my x values is 3. If I add 6, then my x value is 6. So these are my roots. If I were to take the 3 and plug it back into the original equation, I would get 0, which would be the y value. So it's like a 0.30. That's a root. If I plug the 6 back into the equation, I will get a 0. That's my other root. So your 2 roots are 3 and 6. All right, number 2. First step said make sure it's equal to 0. It is. Second step said factor completely. Well, at the top of the factoring diagram is GCF. I have 2 terms this time. I do not see anything that goes into both terms, so there's not a GCF that's going to help us. So I'm over here at the 2 term side. And if it's 2 terms, I am supposed to ask myself, is it difference of squares? Well, difference means it has to be subtract. We do have that. And 2 squares means that we have perfect squares on either side of that subtraction. Well, n squared is a perfect square. It's right in the name. 64 is a perfect square because 8 times itself will make it. So I go straight to parentheses. These parentheses are going to be identical, except one's going to have a plus, one's going to have a minus. So n plus, n minus, and 8 times 8 makes 64. So that's what you would get when you factor. Third step says take each factor and set it equal to 0 and solve. So n is negative 8 and n is positive 8. And there are the 2 roots that you would get from this quadratic equation. All right, number 3. First step said make sure your equation's equal to 0. This one's not. You always want to keep your squared term positive. It's easier to factor that way. So I'm going to move the negative 8 over here by adding. It does not combine with any of the terms already there, so I'm going to make sure the polynomial is in order. Okay, at the top of my list is a GCF. I have one this time, so I'm going to pull out a 2. That's going to give me x squared minus 5x plus 4 equals 0. And now I have 3 terms inside, and front times back makes a 4. 1 times 4 or 2 times 2 will make a 4. The 1 and 4 will add up to a 5, but I need it to be a negative 5, so I'm going to change both signs. All right, so there's no grouping. I don't have to do grouping because there's no number sitting right here in front of that x squared, but I will just to remind people how grouping is done. All right, so when I have grouping, whatever original GCF I pulled out, I'm going to draw an arrow and stick it down here. Reason is if I keep bringing it along, it's going to get sucked back into the problem somewhere where I don't want it. All right, so when you do grouping, the middle term comes out and those 2 go in. So you get x squared minus 1x minus 4x plus 4 equals 0. Groups of 2. GCF of the first group is x. So when you divide by x, you get x minus 1. GCF of the second group, since the group starts with a negative, your GCF is negative 4. Divide both terms by negative 4, and you get x minus 1. So then here's my little 2, which is going to be next to the x minus 1 and the x minus 4, and we still have equals 0. Okay, now see, there's the negative 1, there's the negative 4, and that's what ended up in parentheses. So because there was no number in front of the x squared, I could have skipped the grouping stuff and gone right to that. All right, set each factor equal to 0. You have 3 factors here. 2 times the parentheses times the parentheses. Factors are things that get multiplied together. So you set all of them equal to 0. 2 equals 0, x minus 1 equals 0, x minus 4 equals 0. 2 equals 0. There's no variable to solve for there. And a 2 never equals a 0. So we cross that off. That's what we call an extraneous root. When you get into Algebra 2, you'll learn a little bit more about that extraneous root. All right, so this one we're going to solve. We get x equals 1, and this one we get x equals 4. And there's the 2 roots for our equation. All right, and the last one. B squared equals negative 5b. So set the equation equal to 0 first. Keep your squared term positive. So I'm going to add the 5b. They're not like terms, so I'm going to write them side by side. Okay, now it says factor completely. At the top of factoring says a GCF. I only have 2 terms. They do have a GCF. The GCF is b. So if I divide them both by b, I get b plus 5. And now I notice after I take out the GCF, I don't have any more exponents. If I don't have any more exponents, I can't factor it any farther. So I am done factoring. And the next step says take each factor, set it equal to 0. So there's our 2 factors equal to 0. B is a variable, so one of the roots is 0. B does equal 0. And then this one, when we subtract 5, the other root would be a -5. All right, 6 of them for you to try.